Thank you. Thank you. It's super awesome to be back in Poland, and it's great to be speaking at Infoshare for the first time. One thing I'd like to check, just to start out with, how many of you actually know what Spotify is or use Spotify? Okay, good. I won't spend much time then talking about what Spotify is. I'll get right into the talk. So this talk is actually about how we build products, and it's a kind of a short talk. So it's going to be kind of fast. I'm going to cover a lot of stuff. But if there's, I can take questions, and then there's other talks that I've given, that other folks from Spotify have given, that you can look at if you get excited about some of the ideas I'm showing. So to start out with, I want to give sort of some principles about the way we approach product development at Spotify. This is a quote from our founder, actually, Daniel Ek. I'm not going to read it to you. The important part I bolded, which is that we believe in speed of iteration beating the quality of iteration. And what does that mean? What does that mean? It doesn't mean that we don't care about product quality. We absolutely care about product quality. What it means, though, is we'd rather have lots of short iterations than try and do really, really big ones, right? Not so much Apple. Let's not design something for years and deliver it in one chunk. Instead, we wanted to bring value to users as fast as we can and learn and build better products that way. So that's how we approach product development. And that's sort of central to the way we approach product development. Another thing that's kind of important to understand about the way Spotify works and develops products is that data is more important than opinion to us. Now, what I mean by that is opinion's important, product vision's important, but it's always informed by data, and it's always validated by data. So we gather lots of data. We're lucky enough to have lots and lots of users. So we can look at them in aggregate, anonymized. We can look at them in aggregate and understand what problems we have in the product, what things are working well, and what things aren't. We can also do experiments where we give them new things and see if they like it before we give it to everybody. And this is also kind of important how we work, because that data part is critical. And it may seem that gathering data and trying to be really data-driven and then trying to iterate really fast are actually kind of incompatible with each other, but really they're actually really well tied together, and I'll explain why. Because if you are going really, really fast, but you're not gathering data, you're not learning anything, you're just going fast. Right? It's like running around with your hand over your eyes. You're just going to run into walls over and over again. On the other side, though, if you're gathering lots of data, but you're not actually shipping ever, you're just learning without actually shipping, well, you could actually build the world's best product, but it won't really matter because by the time you actually ship it, all your competitors already own the marketplace, and nobody is going to ever see your product. So data and speed, two critical things to the way we work. Now, if you know anything about Spotify, or if you've seen talks about how we work, you also know something that's kind of important to us is the way we go fast. And some of the things we use to go fast, the most important being autonomy and autonomous teams. And I'm going to talk a bit more about that. I'm not going to go into the Spotify matrix model. It's been covered a lot, but I'll talk a little bit about this autonomy idea. Now, let's talk a little bit about scale, right? So Spotify obviously as a product has scaled fairly well, but as a development organization, we've also scaled well, I think. When I see other people come and talk about sort of interesting ways that they're building their products or building their teams, one of the things that I often ask is how big is your team, right? And a lot of times the teams are so small that it doesn't really matter. You could do anything, and the team would work fairly well because they can all see each other sitting in the same room. But at Spotify, we have a lot of teams working to build our product. In fact, this being our only product, we don't have multiple products. We have Spotify, right? It runs on multiple platforms, but it's a single product. It's built by over 100 teams. I don't know, I actually can't even tell you the exact number because it changes nearly daily. But it's 100 autonomous teams. And that's important. Because when this is the definition of autonomy, I've used the word a few times, this is what I mean. These teams have the freedom to act independently. They can make their own decisions, and they can actually put them into action on their own. This is super important to our speed. And by the way, something I also want to point out, these are full stack teams. Especially in my part of the organization, we build all the features in the product. We build the mobile and desktop products. These teams are full stack teams. They have back end, they have front end, they have design, they have test, they have a product owner. Increasingly, they have analytics, data engineering in the teams as well. So this autonomy lets us do a few things which help us go fast. One is there's no decision-making bottlenecks. They're free to make their own decisions, which means they don't have to come to me to ask what to do. What should we do next? We just did this. What should we do next? And they also don't have to come to me to say, hey, we have an idea. We'd like to do this. Is this OK? They make their decisions, and they tell them to me and my product and design peer later, if at all. They're fully empowered to make their decisions. And it's up to me to decide if I actually really want to know what decisions they're making. So that's one thing, because I'm here this week, right? So I'm in Poland. So if there's teams in Stockholm or New York or Gothenburg that need to ask me a question in order to do their job, I'm here, so I'm not answering it. What does that mean? They'd be sitting and waiting for me to get back. When I worked at Adobe before I came to Spotify, I routinely had to get things approved by a senior VP. And that senior VP was a pretty busy person. And I had to make a slide deck. And I had to go to San Jose and present my slide deck to my senior VP so that he could approve it, and then we could build the thing that we'd been waiting 2 months to get on his schedule to build anyway, that we already knew we were going to build. So we don't have those bottlenecks. Another thing, we don't have dependencies between teams. These are full stack teams. I used to have build products with, probably like a lot of you, like multiple front-end teams, one for each platform, and a back-end team that was responsible for a monolithic web service. The problem is, you want to build a new feature, it requires back-end support. The front-end team has to get something on the back-end team's backlog, negotiate to get it moved up in priority, and then wait for it to be implemented. That doesn't happen for us. We've removed those synchronization bottlenecks because the feature team has front-end and back-end, everything they need to do to build the product and build their ideas. Now, if you come from a kind of more traditional organization like I did, this actually may kind of sound like chaos, right? I mean, you've got 100+ teams, not only with complete decision-making authority, but also the ability to execute on those decisions with like no oversight, right? That sounds insane to people. But I'll tell you, it's not. It really isn't. And I'll talk about how we kind of make that work, right? Because what you think when you hear that is you think, wow, there's 100 teams and they can all do whatever they want. Therefore, like some team's going to say, like, I want to make video games, and some team's going to say, music is stupid. We should do spoken word at Spotify, and they're going to be competing with each other, or conflicting. But that's not actually the case. For us, we actually tend to be more or less aligned. We're not all going the exact same direction, but we're all going in the general same direction, and that actually works fairly well. Because the overhead of trying to make us all go in the exact same direction would slow us way down. So it's okay. But how do we prevent that chaos? How do we prevent one team making video games and one team switching us to audiobooks or something like that? So for me at my level and the C level above me, we have a job. Our job is to provide sort of the what and the why, right? Very, very high level. This is what's important to the business. For me, this is what's important to the consumer organization. This is why we think it's important. Here's all the information that I have, right? Complete transparency. That gets sent, the teams have access to all that information. All the information I have, all the information my peers have, all the information my boss has. The teams then decide, okay, we're going to figure out, we understand what the goals are, we understand what the high-level priorities are, we're going to figure out how we're going to get there, and we kind of meet in the middle. What does this look like in real life? That's kind of an abstract idea. What this looks like in real life, like this is something we're working on right now, something we just shipped. A big priority for us right now, surprisingly, let's grow the monthly active users, right? I've set a target with my peers. We have a strong target that we'd like to hit, and that's the extent. This is the target we have, and this is why we want to hit this target. Hey, teams. This is important to us. You figure out how to get us there. And one of the teams owned navigation, and some other things. And they looked at their data, the data that they had around new users and how they activate. And they realized that a lot of users weren't finding a lot of the cool stuff that was in Spotify, looking at their data, being data-informed and data-driven. So they came up with a hypothesis. We think if we improve navigation in the product, that will actually activate better and retain more users. Okay, so they didn't ask, they just did it. They did some experiments, they validated their hypothesis, and we've rolled out a new navigation system in the last few weeks. That was all done by the team on their own action, or on their own accord. Now, there's one way that I can be sure that those teams are making good decisions, right? I don't need them to come present me all their ideas, but I do want to make sure they're doing the right things. And we have a framework that helps us make those good decisions. It's called Think It, Build It, Ship It, Tweak It. Now this, if you're familiar with like lean software development or lean product development, this isn't anything new. This is kind of our version of it. What we do is we separate sort of idea to ship to every user having it into like 4 segments. And those segments kind of follow the path of the idea, the think it, the build it, the ship it, and the tweak it. Now, the think it part of it, and this graph, by the way, this shows kind of the amount of investment and time, people, sometimes money, but usually opportunity cost is a good way to think about it. So in the think it stage, it's maybe an idea somebody had on the team, maybe one person, maybe they grab another person or two and start like, hey, I think this is a good idea, what do you think? Okay, yeah, let's try it. And they work through some variations on this idea. They may even make paper prototypes with a designer, put it in front of users for user research. They may even code up a version of this feature, put it in the product, give it to employees, and see how employees use it. We may even ship a version, a prototype of this feature to 1% of our users, which is like 1 million people, right? So that we can get data back. And that gives us a lot of information. Is this a good idea? We think it's a good idea. Now we know it's looking like it's a pretty good idea. So that'll be the kind of the gate. Once we're pretty sure this is going to do what we thought it was going to do for the product, we move into build it. Now we're actually going to ramp up our investment because our team is working on it now. And that's a team that could be working on something else, maybe something better. So we really want to use that gate wisely. A lot of stuff never makes it out of think it. Once we hit build it, now we're building it for real. And we'll maybe even roll it out now. We're definitely starting to user test it or continuing to user test it. But we're going to try and minimize this time, right? Because during this time, we're just spending people's time, developers' time, which could be used on something better. We don't know. So we want to minimize this. So we really try and get value to users quickly, have that MVP because we value the speed of iteration. So during this, we'll build the feature. At the end of the build it, the feature's kind of ready to ship. Now, if you build products, you may wonder why there's so much time in shipping it, right? Because once it's in the product, you send it to the App Store and it's shipped. Or you post it, you post it to the website and it's there. We don't work that way. Because now it's ready to actually test for real. Now we've actually built the thing we thought we were going to build. Let's see what it does. So we'll actually roll it out to 1% of our users. Again, the real version of it. And just wait and see what happens. And sometimes, even the stuff we saw when we tested it earlier turns out not to work as well as we thought when we put it in front of real users at scale. And then we end up having to take it back and work on it. So there's sometimes you may get a product, if you use Spotify, you may see a new feature, and it may go away. And you're like, hey, what happened to this feature? I liked it. We see that all the time. It's like, oh, you liked it, but most everybody else didn't, so we killed it. We do that kind of stuff because if most people don't like it and then we ship it to everybody, that'd be a really bad idea. So we actually take our time in the shipping it. It's ready to ship at the beginning of ship it, but then we look at it and how it performs in the market, and we may pull it back, we may do a little iteration, and we're also rolling it out because we work at a really, really large scale. So we also want to make sure that our implementation scales up to our user base. But then we hit ship it. It's now at 100% of our users have it. And now we move into the actual tweak it, because everything up to ship it was based on a real MVP. What's the minimum version of this idea that lets us prove our hypothesis? But it's not like the final version. Now we actually go and tweak it, but we're tweaking it with actual user data and user feedback to understand what's the best way to do this idea. And that tweak it then will continue basically until we hit the point of diminishing returns. But one thing I want to point out to you is that that investment never goes to zero, right? Because once it's in the product, we have to support it forever, or until we kill it. So that's actually an important part, because the team may have moved on to the next feature by getting towards the end of tweak it, but we're still going to be supporting it when the OS changes or other things in the product change. So this is how we make sure, this is how I know that those teams are actually, if they're following this framework well, they're making good decisions. And also, they're minimizing this time in blue. This time in blue is really expensive. This is developers doing stuff that users aren't getting. And for us, that's a lot of time that we don't want to spend. We want to get iterations to users as quickly as possible. Now, I'm not going to go through all the tools that we use, but I will sort of talk, just show you them. These are some of the tools that we actually use in the various stages to actually be data-driven and make sure we're actually doing the right thing. So in the end, though, we've got like 100+ teams all putting multiple experiments into the world at the same time into the same product. We only have one product, and all these teams are messing with the product at the same time. How do we make that work, right? It's a pretty big challenge, right? Because we're also full-stack teams. That means there's not an iOS team building the iOS apps. There's iOS developers in like 20-some teams, each building the same product, but not talking to each other because the teams are independent of each other. So how do we make that work actually in the product development? One thing that's worked extremely well for us is actually creating an architecture that lets us work this way. So we have a very loosely coupled architecture, both in the client and in the server, which actually helps us build with all these autonomous teams working independently of each other and no synchronization. Like, we don't have an iOS meeting where everybody who worked on the iOS product gets together and figures out what they're all doing. That doesn't happen. They all do their own things. So on the back end, that's actually super easy, right? Microservices. Yay, microservices. Everybody loves microservices. We've actually been doing microservices for a very long time, right? Because that's the only way that the way we work works at scale, right? The only way that we can have 100 teams all building back-end architecture, or most of them building back-end architecture, is to use microservices. It also happens to scale exceptionally well. I gave a whole talk on how Spotify builds microservices at GoTo in Berlin in December. If you're interested in that, I would recommend you go see that or watch that talk. It's on InfoQ. But I'll give you some numbers, what the scale is of our microservices. And these numbers are from December, so assume everything's bigger. Everything goes bigger for us over time so far. So in December, 810 active services in production. This is services, not servers. Servers, several tens of thousands, but services, 810 different services running in production, which is about 10 services per squad that's actually building services with back-end engineers in it, right? But that's usually, most of those squads are like 2 or 3 back-end engineers, right, working on it. In fact, it's about 1.7 services per person with access to the production environment, right? So if you can push, that's how I'm determining you have access to production environment. So more than one service for every person who has access to production, but actually more than one service for everyone in the technology organization. That includes coaches, designers, me, that's everybody, right? So that's the kind of scale that we work at, and that's how serious we are about microservices. The client side is much more complicated, right? Because developers can push 1,000 times a day. That's fine. We make that super easy for them to do. But clients, we want to iterate quickly and get stuff to users quickly. Client is hard, right? This only ships once in a while, and when it ships, it all ships at the same time. And actually, all right, I'll tell you something, which is actually for a while. This is the desktop app. For a while, we let teams actually deploy into the desktop app just like they did to play.spotify.com, which meant that your actual desktop app was updating like a web service, which was a little crazy. But it worked for a while. But this desktop product is actually built by lots of teams. And in fact, if you look at the UI, each of these boxes is owned by a different team. But it's still got to look like it was made by one team. You don't care that there's 100 teams working on this. You care that it works and that it looks right and that it feels like it was made by one team, which is a challenge. And honestly, if you look at old versions of Spotify, we didn't always do it that well. In old versions of Spotify, you could actually see the org structure in the product. We've worked really hard to fix that now. And this is how we approach it. Like most of you, yeah, we have a set of shared frameworks that we build on that helps us achieve some level of consistency and not duplicate effort. That number of shared frameworks are actually much, much smaller than you probably build on. It's literally one layer of our layer cake. This is where most of the work happens. This is the feature teams. And they own their full stack. So we don't have many layers of layer cake. We have one layer at the bottom, a big fat layer in the middle, and then a small layer at the top. And that's kind of how we work. So this is how the teams work. These piece on the top and the bottom is how we make sure the product is consistent and works as expected. So at the bottom, what does that mean? That means things like user interface guidelines. We actually publish our own user interface guidelines, not for third-party developers, for ourselves, because we actually need to know how things should kind of work like. Each team has their own designer. There isn't a centralized design team, which means that those designers actually have to know what the product is supposed to kind of work like. It's not a design, like this isn't the design of the product. It's like, this is how a button works in Spotify, right? Similarly, to make that easier, right, so we don't all implement, we used to have like 18 different versions of button on every platform. Now we have one. Teams can make their own version if they have something specific they want to do, but let's just make it easy so we're not all re-implementing the same thing all the time. And then we have shared testing frameworks because we're all working in the same code base and we don't want people to stamp on top of each other's stuff. And we want everyone to add tests that work for everybody. On the top, we have just UI consistency validation. So there's a team that actually is making sure that looking across the product, every team is responsible for its own quality, but then there's a team that looks across the product to make sure that the gaps, nothing's falling between the chairs, as we say. Making sure the teams are also responsible for their own integration testing, but we also have a team that's kind of making sure at the product level that integration is happening correctly. And then there's a team that does the builds and submits it to the store so that every team isn't trying to submit it to the store. And then in the middle, we have things like, we used to actually build, each squad had its own tree, which was crazy, and we had the exact problem you would probably think, which was everybody trying to merge at the same time. That didn't work. We switched to a common tree. And then we also have, if you've heard of guilds at Spotify, guilds actually make sure that we have best practices shared across the organization. Now, in the end, we're shipping this product and we want to ship it faster, and that's been a big problem for us because we can never go fast enough. We can ship the microservices, a backend we can ship as fast as we want, as often as we want. Each developer decides, each developer is responsible for deploying their service. They can do it whenever they want. We can't really do that on the front end, but we want to get this speed of iteration going. So we take advantage of being agile. How many of you saw the talk this morning about Agile, Waterfall, Continuum? Okay, yeah. He and I should be on a panel someday because he's the yin to my yang, or other way around, I'm not sure. Yeah, we don't do that waterfall stuff at all. But I used to, right? I worked at Microsoft for a long, long time doing waterfall, and I worked at Adobe. When I worked at Microsoft, I was working on Windows. We had 2-year, 3-year ship cycles. When I was at Adobe, I worked on the Creative Suite. We had 18, 24-month ship cycles. So we were shipping every couple years. I went to work on a product called Revel, which was a mobile product, and I was like, that's crazy. We're going to ship fast. We're going to learn. So I put us onto a 6-week release schedule. Now, the cool thing about Agile, because you're testing while you're building, you can do stuff like this, which is you can stack your releases, right? Because if you're testing while you're building, when you get, let's say you give that stabilization time at the end, maybe you ship a beta to users, you're collecting bugs, developers have already moved on for the most part, if you've done this well, which means that they're already starting on the next release during that stabilization time, which means that 6-week release schedule actually turns into the users getting a new version of the product every 4 weeks, which is fast, especially if you're coming from 18 to 24 months. time between users getting new versions. But it's not really fast enough. Honestly, it's really slow. So it's 12 releases a year. That's better than one release every 2 years. But we can do faster. When I joined Spotify, Spotify was on a 4-week release cadence, but which that actually turns into 3 weeks because we're stacking our releases, which means now we're shipping 17 releases a year. That's 50% more. That's awesome. It's still too slow. We actually had squads pushing stuff out into the user's hands before it was really honestly ready because they couldn't wait 3 weeks. 3 weeks is an insanely long amount of time for them to wait to ship a feature. And we understand, like we want to be collecting data, we want to be learning. So we've been working, we got it from 4 weeks to 3 weeks, which ends up being new release to users every 2 weeks, which is the world we're in today. That's actually fairly awesome because that is 26 releases a year. But I'll tell you, it is still not fast enough, and we're still challenged because we want to release faster. We want to be pushing several times a day to users. We're not going to really do that to users, but we're trying to actually get our release cadence up even faster because we value the speed of iterations so much. Now, I'm a little bit over time, so I'm going to just wrap up real quickly so I can take a question or two. Just to sum up, though, we want to learn faster than our competition. Speed of iteration is more important than quality of iteration. Speed of iteration means learning to us. We use data to validate our ideas, and it helps us make good decisions while we're going super fast. Autonomous teams actually let us go faster, and that's why we do them. And these loosely coupled architectures let us have autonomous teams. If we had very tight dependencies between teams, we couldn't be autonomous. If we couldn't be autonomous, we'd be stuck and we couldn't go as fast as we'd like. And then the more we get releases out to users, the more we learn. So I'm going to take, I think I have a couple minutes for questions. If for whatever reason you can't get your question to me today, this is my Twitter handle, but I'll also be around all day and at the party tonight. So you can ask me questions then too. Okay, thank you.
Hi, Kevin. Thanks for the speech. I have a couple of questions. Have you started with such free culture, or it evolved from typical corporate closed one? If yes, how did it evolve?
So the model today, we always believed in speed of iteration from the beginning and agile development, but the kind of traditional, well-known part of Spotify matrix model is actually only a few years old. That happened right around the time the company was about 300 people, and we weren't scaling with our agile model well enough. We're using a traditional hierarchy.
Okay. Another question from Victor. One cycle is short enough. At update every it can. One cycle is short enough. No, it's.
Sorry, can I read the question?
Yeah, it is. At update every day it can be.
When is cycle short enough? There's the part we're fighting now is how fast we can go without actually annoying our users, right? So it used to be, especially when we let desktop teams push their own updates, you'd see this, hey, you need to restart Spotify in your desktop browser, and that was happening so much it was starting to actually annoy our users and cause problems. So we actually switched that team to ship on the same release schedule as everybody else.
Okay.
So yeah, that's kind of the limiting factor. We would ship 5 times a day if we could.
One more question. Because you have so many teams working on only one product, is the amount of employees still to pay still profitable?
Oh yeah. Well, I mean, wait, we're not profitable as a company, no. But it's not our costs are determined largely by the cost of the content. And the employees aren't the major costs. And so for us, growing the user base actually helps improve our profitability. So it's more than okay to grow the employee base so that we can grow the user base and then be profitable that way. So that's the way we work.
Okay, thank you, Kevin, very much. Give a round of applause for our speaker.